When you first look at a lead sheet, it is easy to feel overwhelmed. There are dozens of chord symbols staring back at you, and beginners often mistakenly believe they have to memorize hundreds of completely unique, unrelated finger shapes just to play a single song. This excerpt from our class handout shows why that complexity is an illusion. Right here in Section 8, we see that an enormous vocabulary of harmony actually collapses into just 4 foundational 3-note structures, called triads: major, minor, diminished, and augmented. To build any of those 4 structures across any instrument, we use a generative system called chord math. We start by picking a foundation note, the root, and we'll call that N. The golden rule of this system is that when you count half steps to find the rest of the chord, you never count the root itself. You start counting on the very next key or fret. Let's build a major chord. The formula is N plus 4 plus 3. Starting from our root, C, we count up exactly 4 half steps, landing on E. From that E, we count up 3 more half steps, landing on G. That specific mathematical spacing isn't arbitrary. The N plus 4 plus 3 spacing is exactly what creates the open, stable, and happy sound characteristic of a major chord. If we want to change that chord to a minor triad, we only have to make one tiny mathematical tweak. We invert the formula to N plus 3 plus 4. Practically, that just means taking the middle note of our chord and sliding it down a single half step. By compressing that bottom gap, the entire emotional profile of the chord flips. It immediately loses its brightness and takes on a darker, heavier, and more introspective tone. If you play piano or guitar, stacking those 3 notes together is a natural part of your training. But if you play a single-note instrument like a saxophone or a violin, it is incredibly common to look at a chord symbol and feel completely locked out of the harmony section. Look closely at this passage from the text. It points out that single-note instrumentalists already possess this harmonic knowledge, disguised as muscle memory. If you know how to play an arpeggio, you already know how to play a chord. You have simply unfolded it horizontally through time instead of playing the notes all at once. Because horizontal melodies and vertical harmonies use the exact same mathematical building blocks, 3 single-note players can simply divide an arpeggio among themselves. If each player sustains one note of the formula at the same time, they instantly become a functioning harmony section. Let's apply this directly to a real piece of music. Imagine the very first symbol you see on a standard lead sheet is a B-flat. In lead sheet notation, a letter with no other modifiers automatically defaults to a major chord. Pause the video right here. Using our major formula of N plus 4 plus 3, calculate the exact 3 notes you need to play, starting from B-flat. Here is the step-by-step solution straight from the lesson text. We start on our root, B-flat. Counting up 4 half steps brings us to D. From D, counting up 3 more half steps lands us on F. When we map that result out across a chromatic continuum, the underlying geometry is completely exposed. B-flat, a precise gap of 4 to D, and a gap of 3 to F. Taking a few moments in a rehearsal to stop, do the math, and calculate the notes is exactly how working musicians expand a compressed abstract symbol into a live ensemble performance. To complete your harmonic toolkit, we need to cover the final 2 formulas, diminished and augmented. Unlike the stability of major and minor, these 2 structures exist specifically to inject tension into a progression and force the music to move forward. The diminished formula is N plus 3 plus 3. Because both of these intervals are narrow, the notes sit tightly compressed together. This results in a highly unstable, uncomfortable sound, which is why musicians sometimes refer to it as the horror chord. The augmented formula moves in the opposite direction, N plus 4 plus 4. Expanding outward like this prevents the chord from sounding cramped, but leaves it feeling unusually bright, unsettled, and suspended in midair, waiting to resolve. If managing 4 formulas still feels like heavy lifting, look at this instruction from the text. You do not need to memorize the outcomes of every chord today. You just need to build them using the math as you encounter them in the music. After you calculate a B-flat a dozen times, the math naturally transforms into immediate recognition. Keep this grid as your final toolkit. The next time you sit down with your ensemble and see a sheet full of complex symbols, you don't have to guess. You can use these 4 formulas to decode the harmony, turning an intimidating piece of paper into actionable music.